tend to think that the world is very large and that we can do within it what we want, and that biology and biophysics and the biosphere will continue to work as it has in the past, that it's large and substantially immune to disturbance. That is absolutely not true. It's being disturbed at the moment. The fact that the Earth is warming as a result of human activities is a really terrifying fact.
We've clearly already seen that the Earth's climate is changing. And almost independent of what we do to limit greenhouse gas emissions, we will still see some additional climate change. So change has already occurred, some further change is inevitable. What we need to do is to limit that further change.
When you look at the change in temperature in the Canadian Arctic of an expected 5 degrees Celsius, when you look at the changes in rainfall patterns on the prairies of Canada, when you look at the changes that are expected also on the West Coast in terms of snowpack and glacier retreat, it is perfectly clear that if we don't take part in a global process that would slow the onset of the global warming, we are in essentially a suicidal position.
Overall, the climate issue is the most serious environmental, political, and economic issue that I've dealt with in 30 years of public policy. It's not only fascinating, it's very serious, and in many ways it's very dangerous.
We've never had 6 billion people in the world before using all the resources of the Earth to their limits. And now we are diminishing those resources systematically by changing the global environment.
People read every day in the paper about some aspect of this, whether it's a coral incident or dead zones in the oceans or melting ice and no habitat for polar bears in certain areas, and it comes in little packets. And what we've got to do is what we didn't do with the terrorism threat, and that is connect the dots.
We're beginning to see evidence of thinning of sea ice, of diminishing of the ice caps on mountaintops, and other evidence accumulating that the signal of human-caused climate change is beginning to emerge from the noise of natural variation in our weather patterns.
Things are going to continue to worsen as far as climate change is concerned. The question is, how much damage is going to be done before we start getting action on the part of the United States government?
I've said many times, it's the single most complicated and single most fascinating issue I think facing the world. It touches everything. And you can't be a serious student of the future of the world. You can't be seriously thinking about how nations get together. You can't seriously think about the survival of biodiversity on the globe. You can't seriously look at just about anything without factoring in issues related to climate change.
Even though we work on this problem all the time, you got to go back to ground zero and really start explaining the basics of the issue. Because if you don't get the basics, then you don't know what to do about it. And in this particular problem, it's a question of understanding that there is a blanket of gases that surrounds the Earth. And when the composition of that blanket is just right, we keep the temperature of the Earth just right. However, if we increase the gases in that blanket, then we're going to heat up the Earth. And the principal gas that we're concerned about is carbon dioxide. And since Americans and the rest of the world became industrialized in the 1800s and thereafter, we started burning fossil fuels, coal, gasoline, oil, and other fossil fuels, either to heat our homes, to provide electricity in power plants, or gasoline in our cars and SUVs to get around. And as we burn those fossil fuels, they give off carbon, and carbon combines with oxygen, and you get carbon dioxide.
A carbon molecule, CO2 molecule that we release from a tailpipe today stays in the atmosphere for 100 years. So the climate changes we're seeing now are a consequence in large part of the emissions that were made in the 50s and 1960s. Our emissions today are driving the kinds of changes that we will see for 20, 30, 40, 50 years to come.
And so we are now increasing the carbon dioxide in this blanket of gases surrounding the Earth. We've increased it by about 30% over its natural levels, and the more we do that, the warmer it's going to get.
We have already perturbed the climate system beyond the envelope of natural variability, and we know this from measurements of carbon dioxide. we can measure carbon dioxide content in ice cores down in Antarctica, and there are records now that go back 400,000 years, and we know what the natural range of variability is in the atmospheric concentration of carbon dioxide. And we are outside of that limit today.
So this is our freezer. This is where we keep all the ancient ice cores. It's very important to keep it cold, so we have a temperature monitor that just goes all the time, making sure that the cores never get warm. If they get warm, the gases that are trapped in the cores tend to leak out. So now let's go into the freezer here. So this is an ice core. This is what they look like. You can see it's just a nice cylinder of ice. And the amazing thing about these is that they have annual layers in them, usually about an inch thick. Each layer represents 1 year of snow deposition. So when you take a core like this through thousands and thousands of years of climate, you know what the temperature was doing every single year for this whole time. There's samples of the ancient atmosphere trapped in bubbles in the ice. And it's these bubbles that allow us to know how much carbon dioxide there was in the atmosphere in the past, for example, and to ask questions like, did carbon dioxide and temperature change at the same time in the past? How important is carbon dioxide to changing climate? And all of these things. And the answer to those questions is basically, yes, carbon dioxide does change when climate changes, and carbon dioxide is important for the Earth's climate.
A slightly warmer global average temperature is not likely to take out any species to affect maybe one human life. But that's simply the shorthand for climate disruption, or as people are increasingly saying, climate shock. This is not something benign, because it won't come just gradually as a 1/10 of a degree warmer this year than last year. As we know, it comes in a pattern which can be very disruptive.
We also know that the more we provoke the climate system, the more rapidly we send these heat-trapping gases to the atmosphere, the greater the possibility that some regions of the world will see some rather abrupt cooling. Not so abrupt as depicted in The Day After Tomorrow, but perhaps on the order of what we've seen in the record of something on the order of a decade, which is quite rapid.
Ice and snow will cover the entire northern hemisphere. Will reflect sunlight.
Everything is going to get warmer, which would be logical since that's what the words mean. But it actually, probably a better term to use to describe what's happening in our world is climate change. Because as the average global temperatures go up and as we add CO2 to the atmosphere, some places are going to get warmer, some places are going to get cooler. What scientists sort of agree on is that you're going to see more extremes, more drought, more desertification in some places, wetter, heavier rainfall in other places.
These little bubbles here are trapped pieces of air that are 10,000 years old. So these little tiny pieces of air represent, what our ancestors were breathing. We know from these bubbles that atmospheric methane concentration shot up at the end of the last ice age. And what we think that means is that the planet got much wetter in some places and drier in other places. Then 8,000 years ago, the methane dropped at the same time that Greenland cooled, all within 10 years of each other. And what this means is that a lot of the world dried out. And so that, if that were to happen again today, there'd be widespread drought. That's really the most likely way that we humans will feel a climate event like this. It's not through a tidal wave hitting New York City, or certainly not ice in New York City, but more likely through drought and in some places and flooding in other places.
It is true, we're seeing also, for example, more intense rainfall. So that when it rains, more water is coming down. And that is a perfectly logical consequence of putting more heat into our system, into our climate system. More heat means more energy, means more evaporation of water off the land. And that water goes up, it has to come down, and you get more of it in rainfall. So that we're seeing increased intensity of rainfall, not necessarily more, it's not necessarily raining more often, but when it rains harder. So when we see the floods in the Midwest that we've seen in the last decade or so, that again is another sort of harbinger of what's going to happen in the future.
Changing the temperature of the Earth changes all climates. It warms the centers of the continents, for instance, which, when warmed, dry out. And we're watching at the moment the drying out of Central Asia. We have a big drought in Arizona, elsewhere, and everyone has noticed that the forests of North America are burning. They're burning because it's warmer and drier.
We had 255,000 hectares of fires last year, but they were the most intense fires that British Columbia has seen, and when they took off, there was nothing anyone could do to stop them. We lost 300 and some homes, we lost businesses, we had an entire town, the town of Lewis Creek, wiped out. We had to evacuate, 50,000 people, which is the second largest evacuation in the history of Canada.
The same thing is happening all across Asia. I'm told that 13 million hectares of forests in Russia burned this past summer. These are big, serious problems. The climatic disruption has the potential for literally burning civilization off the earth in the course of the next decades.
Where rain falls and where it doesn't has tremendous impact on civilization. The intensification of droughts and floods will pose tremendous problems for society.
In the Okanagan area, where we had the worst of these fires, we had a large sudden rainfall. It was a 1 in 80 year rainfall following this 1 in 100 year drought. The rains caused flash floods. We had mudslides going through the community. People who thought they'd seen hell saw worse. And so the consequences of this, these climatic extremes, these climatic anomalies of extreme dryness, of warm winters, are devastating our ecosystems, and they're destroying our soil, and the siltation is destroying the salmon streams in the area.
Everything in the world is so interconnected that if you go grab one piece of it and pull it out or do something to it, you can bet there will be repercussions that we don't even know now. I mean, sure, the salmon might cease to exist in 50 years in the Pacific Northwest, but all the ramifications of that. Well, look, who would have thought that if you melt the snow a month earlier in the western United States, that would lead to, virtually fatal water problems? You wouldn't have thought that if I just told you that. You would never guess that. But the system is set up in such ways to make use of that. The worst mistake we can make is to assume that the future will be as it has been.
The snow is melting, the ice is melting. People in California, Oregon, Washington that depend on the snowpack in the Cascades, in the Sierras, in the middle of this century, unless we begin to act today, they're going to see that snowpack disappearing and their water supply and their energy supply is declining dramatically.
The bottom line is that the greenhouse warming will cause changes in the water cycle in such a way as to put serious stress on the western United States as we know it within 25 to 50 years. And the stress will show up as just simply lack of water.
It's appearing now in the form of forest fires and drought and various other changes, spread of disease, plant diseases as well as animal diseases.
We've got, for instance, winters where we no longer have 40 degrees below, and as a consequence, we haven't had that for the past 8 years. As a consequence, the pine bark beetle, whose population is normally succumbing, about 80% of the population succumbs to the extreme cold. That population has gone into a superpopulation, and it is at this stage infested 4 million hectares. That's 10 million acres of pine which are dead or dying, and the population is in such a state, even if we had a cold winter like we typically have, the remaining, we're at even only 5%, would still keep spreading. There'd be more beetles than we have pine left, and we expect all of the pine in British Columbia to be destroyed by the beetle over the next few years.
Virtually everywhere we look, we see the greenhouse signal predicted by the current climate models. Not just in the surface temperature, but in the sea ice, the way it's changed, snow cover, the way it's changed, most importantly in the heat content of the oceans. They're an integrator of long-term change, and it turns out that's where most of the greenhouse warming has gone, into warming of the oceans.
One of the most certain effects of climate change or global warming is that sea level is going to rise. And a lot of people are confused about that. It's not going to rise so much because glaciers are melting or the polar ice cap, particularly in Antarctica, is going to melt, which if it did would contribute a lot to it. But a lot of the rise is going to come about simply because as water warms, it expands. So as all the oceans warm up and that water expands, they have to go somewhere. It's going to go up.
Now, it would be simple if the sea level rise came by itself, but it comes with things like storm surges, and it comes with things like tidal change, and it comes with additional consequences that exacerbate some of those smaller shifts.
One of the things we're seeing in the ocean is a changing pattern of the salinity. We're finding that the tropics are getting saltier, and the high latitude ocean, especially in the North Atlantic, is getting fresher. And this is dramatic new evidence for man's impact on the global climate system.
Our climate is stabilized to a certain extent by a heat exchange between the tropics and the Arctic. The ocean currents, in particular the North Atlantic currents, work to bring heat to the northern hemisphere.
Heat from the sun arrives at the equator.
This film, which is a real hypothesis, is that we will be messing up something called the ocean conveyor, which brings warm water from the equator, from areas around the equator, up to the north in the Gulf Stream. And it's water that's more saline, it's saltier. When it gets up into the North Atlantic, it sinks and it forms a conveyor belt that brings warm energy and warm air and moisture northward, cools, and then brings it back down the equator in this sort of conveyor belt thing.
And the amount of heat that is left behind by this ocean circulation is staggering. It amounts to the output of about 500,000 large power stations and has a profound effect on the climate for those regions bordering the North Atlantic, including northwestern Europe and the eastern seaboard of the United States and Canada.
As we warm the planet, and as we add more fresh water from the melting of sea ice, perhaps from increased rainfall, perhaps from some melting in the polar region, as we add more fresh water into this warm, salty water that's coming up from the tropics, we increase its density, becomes colder, and it has a tendency to sink. So as that sinks, if we don't have that big pull coming up, there's some possibility, there's some information in the scientific community that leads us to suspect that this North Atlantic heat pump may weaken and perhaps stop.
The likelihood that it would stop is probably very low, but you don't have to stop it. You simply need to slow it down.
Now we are discovering changes, ongoing changes in the ocean, just in the past couple of years, that suggest that we might be heading towards this type of phenomenon. That is, a shutdown of the conveyor that would tend to cool off Europe and North America.
If a change happens in the North Atlantic region, it can be felt within a year in the tropics. It can change tropical rainfall in ways that are unimaginable according to our previous understanding. So I think the most valuable thing we're getting from studying the past is that the system is more sensitive than we thought.
We don't know how the climate system will react to an ice-free Arctic, to a very fresh North Atlantic that perhaps has lost its conveyor system. We just don't understand enough about the climate system to say what will happen, how growing seasons will change, what areas will still support agriculture, what areas won't.
Agriculture has been adjusted and adapted to the particular climate conditions in each place. And so when climate changes, it almost doesn't matter if it's wetter or drier, it's going to be a problem for farmers.
If you change the weather regime of Europe without dramatic extreme weather events, but just changed soil moisture and the ability to grow crops there, it would have devastating financial consequences, consequences on global food production.
London, Edinburgh, most of Northern Europe freezes up in the wintertime, and where do all those people go? You have all of that investment in Northern Europe, and where is that going to head, and how does that impact in the dynamics of the rest of the world?
Just half an hour ago, Mexican
history over the last 10,000 years, most conflicts have been triggered by a collapse of ecosystems around a society, i.e. their inability to support them either from ecological reasons or resource reasons, lack of fuel, lack of food, those societies do is they raid their neighbors.
Explosive issue in the Middle East. The Middle East is already a political powder keg. If the climate regime were to change dramatically and the distribution and availability of fresh water were to change in the Middle East, it's not hard to imagine that that could provoke what is already a very, very difficult situation.
We're going to see many of the arid and semi-arid areas around the world become even drier. We're going to see agricultural production decrease, especially in the tropics and subtropics, exactly where there's hungry people today. We're going to see the sea level increase, potentially displacing tens of millions of people in small island states and low-lying deltaic areas such as Bangladesh, Egypt and China.
How do we deal with millions of boat people? How do we deal with interventions around the world? I mean, just imagine what will happen when 160 million Bangladeshis have to move, and the places they go are India, China, and Burma. That's going to be a big mess.
There are people on the front lines that we've been to their communities in our ships, and they're telling us the changes are now. We can verify what your scientists are saying, but it's even worse than what your scientists know.
And then there's other kinds of impacts. Let's take another one, which we begin to see already in the system, disease vectors, which is the way of, in scientific jargon, describing where diseases move and how they get around. One of the common ones that we know a fair amount about is malaria. Find it very commonly in the south and the tropics, and everyone advises you to take your shots before you go down there, because if you get bitten by a malaria-carrying mosquito, then you'll get very sick, and it's really rather unpleasant. We've begun now to see malaria-carrying mosquitoes moving up into Florida and into the United States. There's no abrupt change here. It's just that the habitat for these particular bugs and this disease has expanded because things are just slightly warmer and the wetness that they required is available. And that's projected to move northward. That's projected to move into new areas that they didn't used to exist in. And the warmer it gets, and with these kinds of changes in soil moisture and precipitation, that continues.
So while we've got to solve global warming, both by reducing the amount of fossil fuels that we burn, we also need to protect the ecosystems that regulate the climate system of the planet. And that's a major role for both the oceans and for the ancient forests. There's 7 magnificent forests, as we call them, left. 7 ancient forests around the world, and we have spent a lot of time at Greenpeace protecting the Amazon in Brazil. And it's these ancient trees that many have called the lungs of the planet that regulate the greenhouse gases in our atmosphere and help keep the global climate as hospitable as it has been to enable our population to grow to the size that it has become. Trees take on carbon dioxide and they use the carbon to build the woody tissue. When we burn an excessive amount of fossil fuels, we throw an amount of carbon dioxide into the atmosphere that the planet hasn't seen since the age of the dinosaurs. The ancient forests do their best to absorb this. They can even increase their rate of growth. They're overwhelmed by this, however. Then, to make matters worse, when these forests are cut down, all the carbon that has been absorbed into these forests, the trees, the branches, the leaves, and the soil, is released into the atmosphere, magnifying the problem and eliminating one of the great sinks for this carbon dioxide to be absorbed into. So these problems are directly linked, both the burning of fossil fuels and the necessity for these healthy forests to be absorbing at least some of that carbon dioxide that we throw off.
The Earth's climate has already changed, and some further change is inevitable, independent of how much we try and limit our greenhouse gas emissions. We should limit greenhouse gas emissions to minimize the change, but some change is inevitable. That means we're going to have to learn not only how to limit greenhouse gas emissions, but also how we're going to adapt to a changing climate. More extreme weather events, more heat waves, more floods, more droughts, more climate variability. How can we grow the food we need in a warmer world, and in some places a drier world, and some places a wet world? How can we manage an increase in vector-borne diseases such as dengue and malaria? How can we manage sea level rise with greater storm surges? How can we live in a world where biodiversity is threatened and many of our ecosystems are also threatened?
Traditionally, Americans, maybe all people, wait until something spectacular happens before they respond. Probably September 11th is the biggest example of that. Unfortunately, with climate change, there really isn't, once you've had a road accident, once you've had something that really is spectacularly bad go wrong, it's probably too late for us to do anything about it. If we see evidence that the climate has begun to shift abruptly, by that time, there won't be a lot we can do except sort of put Band-Aids on the problem and try and, hunker down and get ready for what's coming, because, it won't be a matter of trying to conserve fossil fuels at that point. It'll be a matter of trying to manage the resources to support the existing populations that are there and get ready for the refugees that will be created by the problem.
The US is about 5% of the world's population, and we emit about 25% of all greenhouse gases. If the rest of the world wanted the same per capita emissions as the United States, it would be a totally uninhabitable planet.
So we are, both historically and currently and projected into the future, a very significant contributor to the problem.
China, India, and the United States all are very heavily reliant on coal. And in China and India, they're just starting to be rich enough to be able to purchase cars. So you're having really rapid motorization.
We currently use 20 times more energy, CO2 emissions, than the average person in India, 10 times more than the average person in China. If they were to use the amounts of CO2 that we emit, the Earth's climate would be many, many tens of degrees warmer than it currently is.
The big hope is that there will be enough economic growth in places like China or India so that they'll kind of leapfrog over our coal-based technology, or our carbon-based technology, we might call it, and go to renewable energy or go to hydrogen as a source of fuel in the future. But that actually is not the pattern that is happening. And if you look at it pretty carefully, they're following our path.
China is the second largest emitter of greenhouse gases in the world. But they're a developing country. There are still 200 million people living in China living on less than $1 a day. And to go to China and say, you need to be doing more to reduce your emissions, when the United States is not doing that, politically it's just a non-starter.
And so there is a real issue of how do we proceed? And the answer is industrialized countries should start taking steps now to decarbonize their energy systems, use the energy we produce much more efficiently, manage our land resources much more effectively. And then as we start to take those steps in the industrialized world, we need to find ways to work with India, China, and other developing countries so that they can also be part of the compact.
Global warming has made the world smaller than even airplane travel. The Europeans are measuring air pollution that's blowing across the Atlantic from the US. The US, people here in the US, are breathing air pollution that's coming from China. So, for the first time in human history, we're challenged with all surviving together, or it's doomsday alone.
This is not a question that any one country can solve. The world's largest emitter is the United States, and it is a much bigger emitter than the number 2 player. But we're only responsible for about 20% of the collective emissions. That's a big number, but 80% has to happen someplace else. Unless you get some kind of an interactive, large-scale international program, you can't solve the problem. So the internationalism of the whole issue, I think, is evident.
In 1992, the nations of the world got together and said, climate change is a problem and we should do something about it. And the developed world was supposed to take various actions and try to get their emissions in the year 2000 to be at 1990 levels. Well, it was pretty clear by the mid-1990s that most countries, including, of course, the United States, were not on that path. We were going to vastly exceed that.
This wonderful work that was done at the Earth Summit in Rio de Janeiro in 1992 has largely gone unimplemented during.
Okay, part B coming soon.